Homework 2.7, 13 through 25. In essence, this is no different than linears. If you remember linear equations, right? If you remember a linear equation, just to go over it real briefly, like y is equal to 1/3 x, or let's go 2/3 x plus 4. Okay, so everything's different, right? And we've got this quadratic, or we've got this linear function. And we start at the plus 4, right? This is your b. That's where we start, right? So, okay, 1, 2, 3, 4. Okay. And then we go up to, right? So we're going to go up to and right 3. 1, 2, 3, right? So we're right here. Does that make sense? And so we make this line. Okay? And that's equals. Now if we go greater than or equal to, or in this case, sorry, less than or equal to, right? Then now, all I do is I put my thing on the line. And if it's less than, I go down, right? And I shade all of this in, right? And then the beautiful part is, if I change this, really? I can't erase this. Oh, there we go. So, if I change this to just less than, then all I really have to do is, let's go a little bigger, I guess. It's probably too big, but is make this dotted. You remember that? Mm-hmm. It's the same thing. It's the same thing with these quadratics. If I have a quadratic that looks like this, right? And it's less than, then I'm going to go underneath it, right? Just shade underneath it. If it's less than or equal to. If it's less than, I'm going to shade underneath it. Make it dotted. No difference. Does that make sense? For some reason, students struggle whenever you throw an inequality at them. It blows my mind. It's like running a play to the right, right? 44 blast, whatever you want to, whatever your plays are called these days. I don't know. I'm back in the day. So 44 blast, we always ran it to the right. Do the fourth hole. 43 blast is to the left. It's the same play, except the fullback goes through the left instead of the right. But for some people, it's tough for them to go left. Right? The same thing. It's the only thing I can compare it to. It's like single leg takedown. If I'm going to single leg somebody, you know, it's really easy to go towards their right leg because that's where I'm always shooting. You know, and going to the left leg, it's a little harder. Right? It's the opposite leg, it's the opposite side. Same thing if you're at bat. You're a right-handed batter, right? It's going to be easy. But you step up left, it's a little harder, right? Okay? Some can do it really well, some can't. The better you can do it switching, the better you can do at whatever it is that you're doing. And here, all we're switching to is an inequality. That's it. So, this first problem, number 13, Is that where we're starting? 13? Yeah. Let me just erase all of this. Start over. And we look at it, and it's y is equal to negative 1/2 x squared plus 3. Okay? And so you kind of you got to graph it.
It's not equal.
Oops, sorry, thank you. So used to the equal sign. Thank you very much. So what was it, less than or is it greater than? Greater than, good. Okay, so it's greater than, and so we're just going to solve it the same way as if it's equal. Right? This is really f of x. Okay? It's y is f of x. So let's just think of it as f of x equals negative 1/2 x squared plus 3. Right? So there's no x in there, right? So where's my axis of symmetry going to be? Does anyone know? Anyone figure the pattern out? Have you figured that pattern out? But where would the axis of symmetry be if I just look at it? You should be able to see this and go, oh, I've done enough of these. But maybe not.
Is it the 3?
No.
No, that's the big one.
It's okay. It is going to shift down 3, right? We know that. We know it's got a horizontal, right? Because it's against the x. A horizontal, it looks like a horizontal compression, right? So, but what's happening here, yeah, it's shifting 3 up, right? So if it's originally looking like this, then it's going to look like this, right? So where is the axis of symmetry? If there's no x, no regular x, your axis of symmetry is always going to be 0. Right? It doesn't move right or left. Unless you see an x. Like, right? Once you see an x by itself, now we know it's going to shift right or left. And that can't happen, this will not happen with x squared plus a number. This will always happen with an x squared plus 5x, 2x, 1/2 x, something x, right? But you'll know it shifts because there's an x there. Okay? But besides all that, get this a little bigger. Okay? How do I find f prime of x then? Because I got to graph this, right? I need 3 really good points. So the easiest points to graph this thing with is, right? When we graph, we got the 4-step plus 1, right? The hardest 2 points are the quadratic formula, right? The easiest 2 points are the y-intercept and 2 times the axis. How do we find the axis of symmetry? Well, we know it's 0, right? But this is how we find it. We go 2 times this, that's negative 1x, right? And then we bring down whatever in front of the x, right? But there is no x, so it'd be like plus 0, right? Because this is basically 1/2 x squared plus 0x plus 3, right? So you bring down what's in front of the x, so it's plus 0. It doesn't change anything. And then you set it equal to 0. But then when I set this equal to 0, right, what does x have to be? What times 1 is 0? Or what times negative 1 is 0? 0, yeah. X has to be 0. Which we should know is our axis of symmetry is fine. Okay? So when we plug in 0, here's the kicker. Right? You plug in 0, and guess what you're going to get? not 0.
C.
C, right? Because that's our, remember, that's our third step. Well, if we plug in 2 times the axis of symmetry, when you plug in 2 times 0, it doesn't move, right? So this one's a tough one to deal with because it's just going to equal 3, right? So we know that we have this graph, and we know that it moved up 3, but we kind of already knew that, didn't we? I mean, we should already know that. We know it goes up like this, right? It opens upwards because it's not negative. Or wait, is it? Oh, it's negative, so it opens downward. So we know it's going to come down. Okay? So this is when you plug in a couple easy points. What are the easiest points to plug in? Well, when you're talking about a 1/2, I wouldn't plug in a 1, right? Because 1 times a half gives me a half. I don't really like a half, right? I don't like dealing with fractions. So how do I get rid of that fraction? 2, right? So if I plug in a 2, what is 2 squared? So f of 2, right, is going to give me what? It's going to give me 2 squared, which is 4, times negative 1/2. What is half of 4? 2. And negative, so negative 2, plus 3, right, is going to give me 1, right? So f of 2 should equal 1. Now if I plug in a negative 2, what's going to happen? Same thing, right? Negative 2 squared is 4 still, right? So it's still going to give me 1, right? And so at 2, 1, 2, 1, 2, it's going to be at 1. So this is our graph. Now, is it equal to? No. So we're going to go like this. Oh, snaps. Forgot I made it too big. Okay. We're going to go like there. I think that's a little bigger. Jesus Christmas. Can we find a middle? Can I get a middle ground somewhere? There. There we go. Alright, so we dot it. Then we ask ourselves, okay, is it less than or is it equal to? Or, I mean, we did that. Is it less than or is it greater than? It's greater than? Then we go up. Greater than is up, right? Okay. So it's everything bigger than this function. Does that make sense? Okay? That's 13. Did I record it?